and welcome to my channel. So today we will discuss force between two current carrying wire. So let us start. We consider wire 1 which carries current I1. Another wire 2 which carries current I2. These two wires are r distance separated. What we are going to find the force of attraction or repulsion between these two wires due to the current flowing through this wire, right? So let us now start. Previously we have found magnetic field due to long straight current carrying wire, and this value of the magnetic field determined by Ampere circuital law, like B equals to mu 0 I by 2 pi r at a distance r. So we will apply this law here. So magnetic field in this position due to current I1 is B equals to mu 0 by 2 pi I1 by r, and it is placed, this point, let's say P is placed at distance r from the current carrying wire I1. Now forget this wire 2, just consider this element, and this element is I2 times dl. I2 dl. So this I2 dl will react with this magnetic field B. So force on this element I2 dl due to the magnetic field at position B. So this represents elementary force on current element I2 dl due to flow of current I through this wire. Therefore the elementary force dF is I2 dl B sin 90 degree. So from where we get sin 90 degree? Come to the picture. In this picture, direction of the magnetic field, this sign represents the magnetic field is going into the paper. So we represent this in 2D diagram like this. This is the direction of the magnetic field B, right? So I2 dl is in this direction and B is here, and the angle between dl and B is pi by 2. So I2 dl cross B simply is I2 dl B sin pi by 2, right? So we have substitute this value. Now I2 dl V sin 90, here we put this B mu 0 by 2 pi I1 by r, and we get the final expression mu 0 by 2 pi I1 I2 by r into dl. This is the value of the force, magnitude of the force for what? The number 1 were on number 2. Now magnetic force per unit length, when we divide df by dl in the previous equation, we get mu 0 by 2 pi I1 I2 by r. This is the final expression. Now the current I1 and I2 are flowing in the same direction. In that case, the force will be attractive in nature. The two current carrying wires will attract each other, right? If the direction is opposite this direction, then the current carrying wire will repel each other. Now I have a simple question on my mind: how this direction changes the nature of the force. I want to say, when in same direction the force is attractive, and when current flows in opposite direction the force is repulsive. How? So let us try to find the answer. When current flows in opposite direction, here is the element dl, so I to dl has the direction here, and obviously the magnetic field due to this current I1 is in this direction. So using Maxwell's screw rule, we get the direction of the force along this. So obviously they will repel each other. Before saying thank you, I have also another question in my mind. When current flows through a wire, Oersted proved that there is a magnetic field around it generates. How? We know current is charge passing throughout any time, then there is flowing charge here. So how this charge creates magnetic field? There should be electric field instead of magnetic field. So who will answer this? Please comment. Thank you.